Hi, Matherinos. It's time to take a look at our feedback. Taking a look at our feedback, we're going to look at the completing the square section and the newest section, which is some systems of equations. Looking at the completing the square section, the biggest issues that I'm seeing for those of you that are attempting the problem are not with really the first part. I'm seeing a lot of people do this okay. So the first thing we have to do is to make sure that we figure out what we want this equation to be. And we know for this thing to be a perfect square, we've got to take that middle number, divide it by 2. That's going to be -4. That's going to be important in a second, so I'm just going to ID that. And then -4 squared, which would be +16, is going to go up top. Our goal is to make this be this equation, and in order to do that, I've got to change 12 to become 16. To get 12 to 16, I'm going to add 4 to both sides. And when I do that, and the other thing I'm going to do is change this b of x to y. We're having trouble kind of figuring out what to do with that b of x. They just mean the same thing. This is just so we can have more than one equation on the same page. So I'm going to write y plus 4, and that's going to be equal to x squared minus 8x plus 16. The next step is to factor the right side. But we've talked a lot about a shortcut we can use here. And we know this is going to factor into a perfect square. We also know that based on the number we got when we divided over here, in other words, -4, that's going to be what's inside my parentheses. So x minus 4 squared would be what we get when we factor this. It's always going to be that b value divided by 2. And finally, if we go y is equal to x minus 4 squared minus 4, we have our vertex form. Generally, people are doing okay here. The vertex is going to be the opposite of the inside, +4, and the number for the outside, which is -4. And when I put that on my graph, so that's going to be at 4, -4. I saw some people miscount. That's okay. Since that coefficient is 1 in front, we're going to go up 1 and over 1 on both sides. And sometimes it's nice to put the y-intercept in as well. In this case, the y-intercept would be 12, which doesn't really fit on our graph. That'd be somewhere up there. So maybe not. And then finally, we need to see some kind of a parabola as a shape. And it's going to look something like this. That's definitely the best parabola I've drawn on here in a long time. At that point, you're done. In terms of the equation of a circle, people generally did really well with getting the center. In this case, the center would be the opposite of both things in parentheses. So 5, -3. And the reason that it's the opposite for both instead of just the x is that both of these are inside of a function. That's that thing squared. And the radius, r squared, is equal to 9. Therefore, r is equal to 3. So if I go over to 5, -3, that's my center. And what I'd really like to see for a radius of 3 is you going up 3, right 3, down 3, and left 3 from the center. And just try to draw a circle that hits those points. If it's anywhere reasonably close to that, even if it looks kind of like a square, that's okay. Well, it's not really okay. It's kind of sad, but that's okay. But I need to see that you're trying to get out to those 3 radii. I'm seeing a lot of circles that end up with like weird pieces like this, and the other side's okay. Then I'm going to take points off for that because you're not showing that you know how to do the radius correctly. Moving on to the next part, we've got systems of equations. And the first one, it looks to me like this is set up really nicely for elimination. These things are stacked really well. And what I'm going to try to do is to make some of these coefficients be the same. It looks like that might be a good target because y is 1 and I've got a -1 for the other one. I'm going to multiply the whole bottom equation by 5. That would give me 10x plus 5y and 15. and I'm going to keep the other one the same, so 3x minus 5y and equal 11. Since these are opposite signs, I'm going to add those two equations together, and we get 13x, 0, that's what we're going for, and 16. When I divide, I get x is equal to 2. The next thing I need to do is plug this back in. I like using this equation because there's less stuff in it. So we get 2 times 2 plus y is equal to 3. If 4 plus y is 3, that means that y has to be negative 1. You need both the x and the y in order to finish solving this. For number 11, a lot of us are kind of getting past the first step, which is to say that x squared is equal to 4x plus 12, and then not knowing where to go. If this thing is quadratic, that is, it has an x squared, we know we need to get everything on one side first. So I'm going to minus the other stuff, keep the x squared positive, to get x squared minus 4x minus 12 is equal to 0. And as soon as I do that, by golly, that looks factorable. All right, so I'm going to do a times c, which is negative 12. b is negative 4. That's going to be negative 6 and positive 2. Doing some factoring, we end up with x minus 6, and x plus 2 is equal to 0. That means that x equals 6 and x equals 2. However, I'm not done. I have to then plug these things into an equation. I'm going to use the bottom one because that looks a little bit easier. I also lost a negative on my 2. Okay, so if y equals x squared, y equals 6 squared, which is 36. That's one of my answers, 6 and 36. And then my other answer, if x equals negative 2, y equals negative 2 squared, which is 4. So y equals 4, and x equals negative 2 would be my second answer. For number 12, this is the word problem. And here we've got a bunch of penguins selling scarves and mittens. I'm going to say x equals the number of scarves. I don't like using s as a variable. It looks like 5 to me, case in point. Y equals the number of mittens. And when I look at my first bit of information, 71 total scarves and mittens. So that means that 71 is equal to the total of these things added together. X scarves plus Y mittens gives me 71. And then scarves are $5, mittens for $8, and total of $4.24. So they made a total of $4.24. And that's the number of scarves, which is X times 5. And the number of mittens, which is Y times 8. So this is a cost. This is a great elimination problem. So I'm going to multiply these guys both by negative 5. Okay, 71 times 5 is going to be 355, and that's negative. X times 5 is going to be 5x, negative, and we want this to be negative, that's right. And then we get negative 5y. Okay, so that's going to give us 3y, and when I subtract these two, oof, this is fun. So that's going to be 124 when I minus 300. It's going to be 74 when I then subtract, I completely lost track of what I was doing. So it's, all right, I'm going to start over again. It's going to be 124 when I minus 300, okay? 74 when I minus 50 more, and then it's going to be 69 when I minus 355. Okay. And that means that y, the number of mittens, is going to be 23. Okay, looking at my original equation, if this is going to be 71 is equal to x plus 23, minus 23 would be 51, 48. So 48 is equal to x. So in looking at this, we're going to have, they sold, and you do need this last sentence, 48 scarves and 23 pairs of mittens. it doesn't really say pairs, but I'm going to make an assumption that penguins don't sell one mitten at a time. And that's it. The key points here, we identified what the variables were, we made some equations, we solved the equations, and we wrote some kind of an answer in the context of the problem.